batteries. Batteries. Right. Okay. So I've got a few different batteries here. I have a D cell battery, a C battery, and a AA battery. If you inspect them closely, you will notice that this AA battery has 1.5 volts. So if you had to guess, and you see how little this AA battery is and how big this D battery is and how many volts this D battery has, I wonder what your guess would be. Let's see if we can set this up so you can actually read it. Where does it say? It says on there somewhere. I found it. There it is. See that right there? 1.5 volts. They're both 1.5 volts. Why is this battery so much bigger than this battery? Probably just so they can charge more. No, it's not so they can charge more. It is more chemicals in this, right? So it will last longer. So this is a battery that'll last longer. This is a battery that takes up less space and weighs less, right? So sometimes you might want different ones of those. But really, all these like cylindrical style batteries, those are all 1.5 volts. There are batteries of different voltages. There are 9-volt batteries. Guess how many volts are in a 9-volt battery? 9. Good job. And little button batteries. Like there's lots of batteries for different applications and that kind of stuff. But a lot of your generic batteries, right? They're just 1.5 volts. That has to do with chemistry stuff that we're not going to worry about. AP chemistry worries about galvanic cells and that kind of stuff a little bit. But if we want to measure the voltage, right, it says 1.5 volts, but what if we want to measure that? So if we hook up to our little voltmeter here, I'll lift up the voltmeter when we're measuring so you can actually see what it's telling us. If we hook up our voltmeter to our battery, the battery tells me it's 1.5 volts. So if I look at it, it says 1.5 volts. Oh, wait, no, it's a little less than 1.5 volts. So part of that, a couple of things, like how great is this voltmeter? Probably not perfect, but they never counted it really 1.5 volts for a couple of reasons. One, that is the theoretical voltage on here. It's often a little less than that because there's internal resistances within the battery. There's also resistances in these little wires. This battery, I think, is a little older because normally you actually get about 1.2 volts or so out of those. If I take a second battery and hook it up here in series, right? So there's one after the next, and we hook it up to our voltmeter and check now. Now it's at right about 2.1 volts. So we were just under 1. So this one actually was about 1.2 volts. So that's kind of the, it's probably in a little better shape, a little more life left in it and stuff. Right? So we can see how we can measure those. If we think about how this would work, right? I talked about having a short. This isn't a short. If I hooked up my ammeter, which we'll talk about another day, to this, that would actually be a little bit of a short because there's no job to do. But if I want to measure how hard something can push, I can't let it push me. I have to resist it, right? So this has a lot of resistance in it. This is like a wall, basically. The electrons go and they push on it as hard as they can, but they can't get all the way through, right? So that's how this would work. If we want to see, well, what do we do with that kind of job? I have a little fan set up here. I went back to just one battery. So now I've got both batteries, but I'm only hooked up to the first battery. So I have just the one battery, and then we'll hook that up to our fan and kind of see how that's going. I don't know how well you can hear it, but if you listen and you look at it, you can maybe get a sense for how fast it's going. In person, you can tell very easily how fast it's going. Now to two batteries, that is going a little faster, right? So I don't know how well you can tell that, but it is definitely going a little faster. In person, it's real easy to tell. Stop slamming into I need a screwdriver to tighten that guy down a little bit. So this was about 2 volts. If I hook it up to a 9-volt battery, how would you expect it would move? I bet you're going to say faster because you're smart. And it is. Look at that. Whoa, calm down. It is definitely moving faster. That might even be messing with my voice. I've got it next to the microphone over here. Definitely moving faster. Move it up to the screen. I don't know how, it's a fan. You can't really see it. I don't know what I'm expecting you to see, right? But light bulbs are brighter. Fans go faster, all that kind of stuff. We send more electricity through them, right? So anyway, that's that. And we'll pick this up tomorrow.